So the asynchronous inputs using JK flip-flop with active low preset and clear inputs is shown in the circuit, where J input, K input, this is the clock, but since we have to change the state Q without using the clock, that is, if we want the flip-flop to change the state with the help of this preset and clear bar, as seen before, we don't select clock and we select preset bar and clear bar correspondingly as per the requirements. So now let's take an example of how the things work, how the things can be worked out to obtain the different kinds of circuit diagrams, plus also we can see how the circuit works with respect to the clock change. Let's take a simple example. For example, this is the circuit. You say this is the circuit. Here both inputs are given 1 1. This is the clock J, this is kth input. Okay, now what will be the output? So how the things will be work, or how this flip-flop will work? Let us assume the initial output Q. Okay, let's take a big pretty neat figure. This is a JK flip-flop, small input of as a clock. This will be Q bar. Okay, so the inputs given here are 1. So what will be the next state, or how correspondingly will the flip-flop work? So let's assume initially Q is 0, so Q bar will be 1. Okay, so during the first clock pulse, as we have seen, when J is 1, K is 1, the JK flip-flop toggles when both the inputs are 1. So during the first clock pulse, Q will be 1. Therefore simultaneously Q bar will be 0. Again, during the next clock pulse, J is 1, K is 1. So Q will be 0, Q bar will be 1. So in terms of clock pulse, we can see how this works on. Okay, let's say this is the clock pulse, this is the clock pulse, this is a rising edge, this is rising edge, this is rising edge, this is rising edge. Okay, so as we can see from the symbol of the clock pulse, which is a positive edge triggered, that is, the output state of Q will change only when the clock changes from 1 to 0. Oh, I'm extremely sorry, I've made some mistake. This is not the rising edge. This is the rising edge, rising edge, rising edge, rising edge. Okay, so as seen from the circuit diagram, the output of the JK flip-flop changes only when the clock changes from 0 to 1, since it is a positive edge triggered flip-flop. So we can work out with the output of the JK flip-flop. Let's start with 0. That is, as we have assumed initial state or the initial output of the JK flip-flop is 0, so we assume by 0. Since it is a positive edge triggered flip-flop, the output changes, or the state Q changes when the clock changes from 0 to 1. So in this case, the clock changes from 0 to 1, so we can see that the clock output of Q changes from 0 to 1. Okay, it continues to stay in 1 until there is a next rising edge. So here we see a next rising edge. In this part we see the next rising edge. So the output goes down. That means the next stage shows 0 to 1. This 0 to 1, initial state was 0, the next state was 1, again the next stage is 0. So we see the rising output state changes from 1 to 0, that is from this 1 to this 0 when there is a rising edge. So this flip-flop keeps on continuing at the 0th stage until there is a next rising edge of the clock. Now we can see the next rising edge of the clock, which is 0 to 1. So again the flip-flop changes from 0 to high state, and it continues to be in a high state or 1 state until we get the next rising edge. So the moment we get the next rising edge, it goes down and it continues to remain in the 0, and this continues. Now the toggling state, we can see it goes from initially 0 and this 1, this 0, that is 0 1 0 1. This toggling stage is observed because we have both j is equal to 1, k is equal to 1. Therefore we get this toggling stage. So let's find out the frequency of operation. Let us assume first is to find the frequency of operation. Okay, first stage, let's assume input frequency is 10 kilohertz. Okay, so as we can check out, this pulse is this one, that is from this to from this, it is t, and as the output of the flip-flop changes from one t to other t, that is we can check out from one t to other t, it is 2t. Again it continues to stay in the same state for 2t state, and again this for 2t state. So we can find out the operation of the flip-flop or the frequency. Since both the input for JK are 1 1, the output toggles on positive edge. Let t be the time period, as I have told, for the clock pulses. Okay, so the waveform, output waveform, this is the output waveform of JK. Output waveform. This is the output waveform. So the output waveform is 2t. Okay, where t is time period. Okay, so let's see. So f, how to find the output frequency? So f will be t by 2, that is f will be, since the time period or the frequency is given as 10 kilohertz, so we write it down as 10 by 2. Therefore the output frequency is equal to 5 kilohertz, or we can also say output frequency is equal to f clock by 2. This is the output frequency. Let's take one more example to find out the output frequency or the working of flip-flops. Let's say the circuit diagram for the flip-flop is as follows. This is Q bar. Now the Q bar is given as an input. Say this is D and clock. Let us assume initially it is 0 and 1. Let's draw a neat diagram. This is Q bar. The Q bar is given to D. Okay, this is a clock pulse. Let us assume initially Q is 0, therefore Q bar is 1. This 1 is given here. Okay, so during the first clock pulse, okay, this is the clock pulse. So this is the initial stage where initial output is 0, Q bar, initial Q bar is 1, and this Q bar goes as an input. So during first clock pulse, we can verify with the truth table of the D or the we can verify with the truth table of D flip-flop. During first clock pulse, when D is 1, Q is 1. That is, sorry, when D is 1, Q is 1. That's right. So during the first clock pulse, it will be 1. This will be 0. Now during this second rising edge of the clock pulse, this will go here, so 0. So during the second rising edge it will give 0, it will give 1. Now this one goes again here, so the next stage will be 1 0. So let's check out the timing diagram for the D flip-flop and the output clock frequency, how it works. Let's say this is the